Okay, today we're going to be looking at graphing relationships. This is going to piggyback off the last lesson we had when we were on our Chromebooks and we went to desmos.com and we were graphing some scenarios that we saw in videos. And today, instead of watching a video, we're going to be reading the scenarios and graphing them. So when graphing situations like this, the first thing you want to do is look at your graph to see what the x-axis and the y-axis are actually representing. On these graphs, you will look and see that the x-axis is all time, and the y-axis is representing the temperature. So we're going to look at what happens to the temperature as time elapses. So as we read through this scenario, we want to look for keywords that will tell us, give us an indication as to what the graph will look like. So the air temperature was constant for several hours at the beginning of the day. So if it was a constant temperature, the temperature was not changing. So if you look down here at graphs A, B, and C, you will see a straight line on this one, which would indicate that the temperature did not change. Here, the temperature did not change. In this graph, you can see the temperature was rising. So this would not be a graph that fits this scenario. And then it rose steadily for several hours. In both graph A and B, if you look down here, you will see that there is a steep increase, which shows that the temperature is rising. And both of them have a pretty steep incline, which could represent rising steadily. Next, it says it stayed the same temperature for most of the day. So think about how much time has elapsed. Most of the day would be a large amount of time. In graph A, it stayed warm, but the time that elapsed was very short amount of time. On graph B, it's a longer amount of time. So that would make sense that graph B would be the answer. But let's check the rest. Before dropping sharply at sundown. In graph B, you will see the decline in temperature. Notice in graph A, there was a decline, but then if it had continued and said that the temperature remains steady throughout the night, that would be this part of the graph. So graph B would be the best graph for that scenario. In our next one, we have to again look at the graphs to see what the x-axis represents. Time again. Our y-axis is the number of leaves on a tree. So we have to think about how many leaves would be on the tree to begin with, and then what happened with all of those leaves. So let's read the scenario. Each day, several leaves fall from a tree. Well, for leaves to fall from a tree, you have to assume that the tree has leaves. Well, in all of these, you will see that the tree starts with leaves. It's not on 0, somewhere up there on the graph. Graph A would indicate as it's rising that the number of leaves increased. Nothing in our first sentence led us to believe that it was springtime and that the leaves were budding. It just started with the leaves falling. So graph A, since it begins with leaves falling from a tree, would not be correct. One day, a gust of wind blows off many leaves off the tree. A gust of wind, so the number of leaves declined pretty quickly. Well, here on graph B, you will see that the number of leaves dropped pretty sharply, which could indicate a gust of wind. Over here, it said each day several leaves fall from a tree, and then when the gust of wind came, the number of leaves stayed constant. Well, I don't think the number of leaves stay constant when a gust of wind comes along. So that would be, again, graph B. That would be the best graph to represent that information. Now, we actually need to learn the difference between a continuous graph and a discrete graph. I'm going to go back to the slide before. When you're talking about air temperature, temperature does not rise incrementally from for example, from 70 degrees. It does not automatically jump to 71 degrees. and then does not automatically jump to 72 degrees. It 70, then like 70.1, 70.2. There's a gradual through every decimal and fraction between 70 and 71. That would be represented as a continuous graph with a line, showing that it's that temperature and every decimal in between. This next one, I actually think it should be a discrete graph, although I copy and pasted this off of the internet, and they have it as a continuous graph. But the number of leaves, let's say you began with 500 leaves. Every time a leaf falls off, you lose an entire leaf, not part of a leaf, so that would go down to 499 incrementally. That could actually be represented with points on a graph, and this is what a discrete graph is. You don't lose portions of leaves, the whole leaf falls off. So this one could actually be graphed as a discrete graph as well. They have it as a continuous graph. But in our next scenario here, we have a truck driver. We have to think about the time that elapsed in relation to his speed. So a truck driver enters a street. Okay, when you enter a street, you begin to accelerate. Then he drives at a constant speed, and then he stops. Well, in order to stop, you have to deaccelerate and then come to a stop. So if you look down here at the graphs, this one has us starting at 0 speed. This one has us starting at faster than 0, and this one's even faster. So we could approximate this and say maybe this is about 30 miles. Maybe this is about miles per hour. Since the numbers are not there, we're just guessing. Maybe this is 70 miles per hour. Okay, well, when he entered a street, hopefully he was not going 30 or 70 miles an hour. He probably entered a street, drives, accelerates, and it says he drives at a constant speed. A constant speed is indicated by a straight line going across. So as long as, I don't know if you can enter a street at 30 miles per hour, but there's the constant speed. And then stops at a stoplight. In order to stop, you have to deaccelerate and come to a stop. There is no deacceleration here in coming to a stop. Because when you come to a stop, the speed would be 0, and 0 is represented at the bottom of the line. So it's obvious here that graph A is going to show him accelerating, constant speed, coming to a stop, accelerating, constant speed, coming to a stop, accelerating, constant speed, coming to a stop. So graph A would be the best one for that. That is another example of a continuous graph, because again, speed does not automatically jump from 30 miles per hour to 31. It would actually be 30, 30.1, 30.2, and every decimal in between. So we do this with a continuous graph. I will start part 2 in just a minute.